Welcome back. This is lesson 7.8 part 2, the distributive property. I will be able to use the distributive property correctly by distributing the multiplication to each term inside the grouping symbols. I will also be able to simplify by using the distributive property correctly. Okay, vocabulary for this lesson. You're going to need the vocabulary page. We're going to finish filling that out from the Chapter 7 vocabulary words. So go ahead and pull that out, the second page. Okay, we're going to talk about distributive property, factoring, and equivalent expressions. Alright, find where it says distributive property on your vocabulary sheet. Alright, the distributive property is the property that allows multiplication, allows numbers from the outside to be multiplied with each term on the inside of grouping symbols. As long as it is a sum, meaning you're adding inside, or difference. So, here's an example. We have 3 outside of the parentheses. Inside we have a sum of 13 and 4. So what we can do is we can distribute or share the multiplying of the 3 to the 13. So that would be the same as 3 times 13 plus 3 times the other term, so 3 times 4. So 3 times 13 would give you 69. 3 times 4 would give you 12. So that is how you can use the distributive property to simplify an expression. Now, factoring is going backwards. Factoring is to use the distributive property backwards to pull out a common factor to create multiplication with grouping symbols. So, an example, we have a difference. I can see that both of these have a common factor of 9. So this is 9 times 7, and this is 9 times 5. So I can rewrite that by saying, okay, 63 is 9 times 7 minus 9 times 5. Now because 9 can be multiplied to both of those, I can make 9 groups. So if I make 9 groups, I can pull that outside the parentheses. And that the same could be as said that I have 9 groups of 7 minus 5. Alright, now that we've got those definitions written down, let's go back to your journal page. We are going to be applying these to algebraic expressions. So here it says, write out in words what each expression means and then make a model for each expression. So this right here says I have 3 groups, that's what's on the outside, of 4 and D. So we're going to make a model of that. So we're going to make 3 groups. So there's 1 group, 2 groups, 3 groups. And in each group, there's going to be 1D. So remember when we make models, we use sticks for the variable and squares for the ones. So, and 4. So 4 plus D. Here's another one. D and 4 little squares. D, and 4 little squares. So here is an exact model of this. 3 groups. In each one there are 4 and D. So if I were to simplify this and just tell you what I have, I would tell you that I have 12 squares and 1, 2, 3 D's. Alright, let's try this one. Here we have 2 groups of what and what. Inside, 2 groups of 6 and 4. So, to make a model of that, 2 groups, there's 1 group, there's 2 groups. I'm going to have 6 and 4, 6 and 4. Alright, that's a model of this exactly. 2 groups of 6 and 4. Now, if I simplify this, you could tell me, well, there's 10 in each group, and I have 2 groups of 10, so that would be a total of 20. There's my simplified expression. So, here it says, use the distributive property to simplify each expression so that there are no more grouping symbols. So look at what we did up here. You can see my 3 groups, but you can see my simplified expression. Isn't this 4 times 3? Isn't this 3 times D? So all I have to do is, I could draw a model here to see all this, but I just have to know that I would have 5 groups of 2. So to simplify that, I do 5 times 2 plus 5 times D. And if I did that, 5 times 2 is 10, plus 5 times D is the same as 5 D's. This simplifies to become 10 plus 5D. Alright, let's do this one. 3 times 6 plus, no, minus 3 times 4. So this would give me 18. This would give me 12. No, I can leave it there. I can go farther and say that this simplifies to 6. But, do you see my 3 times 6? Do you see my 3 times 2? Or, sorry, 3 times 4? In the end, though, because these are both numbers, I can simplify it just down to 6. This one here, I can't because I can't combine D's and my constants. Alright, this one here, 2 times 3p. So if I were to draw a model, I'd draw 2 groups, and in each group there would be 3 p's. And then I would be minusing 1 out of each group, so minus 2 times 1. So 3 times p is the same as 6p, minus 2 times 1 is 2. And that's as far as we can go because those are variables. We can even do it with decimals. So 0.5 times 10 plus 0.5 times 4. 0.5 times 10, anything times 10 is going to move the decimal over 1. This is the same as timesing by 1/2. So I'm going to get 5 out of that. Oh, h. Don't forget that, that's 4h. So 0.5 times 4h would give me 2h. Now this one, there are 3 terms inside. That means I have to do the distributing property 3 times. So as long as it's plus and minus in here, it'll work. So 3 times x would give me, so I'd have 3 times x plus 3 times y minus 3 times z. Each one of those is getting multiplied by 3. Now simplify, that would be 3x plus 3y minus 3z. Same thing here. I have numbers, so I'm going to do 8 times 4 plus 8 times 7 minus 8 times 1. 8 times 4 is 32 plus 56 minus 8. That is simplified, but not as simplified as possible, so we can add these all together. 32 plus 56 would give me 88, and then 88 minus 8 would give me 80. Now I can simplify this one down because these aren't variables. But I want you to see where this comes from, this up here. Now down here it says make a model to show how to factor each expression into groups. So if we make a model to show how to factor each expression into groups down here, we're trying to turn each of these into equal sized groups. So I've got to have something that divides into both 9 and 6. So what is a number that you know that divides evenly into 9 and into 6? Okay, well that would be the greatest common factor. So our greatest common factor of 9 and 6 is 3. So if I know that, that means I'm going to be making 3 groups. So let's make our models. 1 group, 2 groups, 3 groups. So if I split 9 into 3 groups, that would put 3 squares from 9 in here, 3 in here, and 3 in here. If I split 6 into 3 groups, that would put 2 in here, 2 in here, and 2 in here. So, if I factor this expression, I can make 3 groups, and in each group there would be 3 from the 9 and 2 from the 6. Okay, let's take that same idea to here. What's the greatest common factor of 4 and 10? What can I divide both of them by to make equal sized groups? Okay, my greatest common factor is 2. So I'm going to make 2 groups. So in my model, there's 1 group, 2 groups. So if I split 4 J's into 2 groups, that would put 2 J's in here and 2 J's in here. So in each group I would have 2 J's. If I split 10 into 2 groups, that would put 5 1's in each group. So in each group I have 2 J's and 5 1's. Now you can see that 2 times 2J would give me 4J, and 2 times 5 would give me 10. Here is an example of it being factored out. So 3U plus 12. 3U and 12 share a greatest common factor of what? 3. 3 goes into both of them. So I'm going to be making 3 groups. 1, 2, 3 groups. If I split 3 U's into 3 groups, that puts 1 U in each group. There's my 3 U's total. So that puts 1 U in each group. If I split 12 into 3 groups, that would put 4 1's in this group, 4 1's in this group, and 4 1's in this group. So 3 groups can be made out of this, and in each group I'd have 1 U and 4 1's. There is my factored expression. Now down here it says use the distributive property to factor each of the following expressions so to create an equivalent expression with grouping symbols. So same idea, we're just not going to have to model it. So what can go into both, we're going to find the GCF of all of these. What can go into both 12 and 15? 3. Okay, if that's the case, let's rewrite this as 3 times something and this as 3 times something. Well, 12 is the same as 3 times 4, and 15 is the same as 3 times 5. So what does that tell me? It tells me I can make 3 groups. If I split 12 into 3 groups, there would be 4 in each group from it. If I split 15 into 3 groups, there would be 5 in each group from it. So this can factor to 3 groups of 4 plus 5. Let's try this next one. Greatest common factor here. Something that goes into 18, 16, and 4. Well, 4 goes into 16 and 4, but not into 18. So I think the only one I got is 2. So we're going to be making 2 groups. So I'm going to rewrite this as 2 times 9 minus 2 times 8, there's 16, plus 2 times 2 gives me 4. So now that I know what gives me each of those, I can make 2 groups, and there would be 9 in each group from this one, minus 8 from each group in this one, plus 2 from each group in this one. This expression factored and made into a equivalent expression with grouping symbols looks like this. Okay, let's look at 16m minus 12. Greatest common factor. What goes into both 16 and 12? 2 would work, but 4 is the biggest one. If possible, we like to do it with the greatest common factor. So, I know that I can change this to 4 times 4m. That's how I get 16m minus 4 times what gives me 12? 3. Okay. So that means I can make 4 groups, and in each group there would be 4 m's minus 3. Okay, what's the greatest common factor of 35 and 14? 7 goes into both of those. So this is the same as 7 times 5 minus, this is the same as 7 times 2d. So if I make 7 groups, there would be 5 in each group from the first number, minus 2 d's in each group from the second one. Okay, let's try this one. What do all of these share in common? Looks to me like they each share 3 goes into 12, 3 goes into 6, and 3 goes into 9. So my greatest common factor here is 3. So 3 times 4z would give me 12z, minus 3 times what would give me 6m? 2m, plus 3 times what? 3 times 3g. So 3 groups, if I make 3 groups, I would put 4 z's in each group, minus 2 m's, plus 3 g's. Alright, let's try this one. Ooh, I know 5 will go into both of these. Oh, 55 will go into both of these. This is just 2 times 55. So, greatest common factor here is 55. So, this would be 55 times 2h plus 55 times 1f. So, to make this into grouping symbols, I could make 55 groups, and in each group there would be 2 h's plus 1f. Alright, so down here it says write 2 other expressions that are equivalent to the expressions given. Okay? On this one I can use the distributive property. So I can do this and I can get 4g plus 4 times 5 is 20. Okay, what's another thing that could be equivalent to these? What if I pull out a 2? Look, these both have a common factor of 2. So if I made 2 groups, in each group there would be 2 g's plus 2 times what gives you 20? 10. That would be an equivalent expression. Okay, I want you to write one more that could be equivalent to any of these. Okay, actually, I want you to write 2 that could be equivalent here. That's your assignment, is to finish this. Okay, and then rate yourself 0, 1, 2, 3, or 4. How do you feel about using the distributive property and turn it in on Google Classroom?